Hello, welcome everyone that's coming in. We're going to give everybody a few minutes to come in, but if you are already in the Zoom and can hear me, go ahead and introduce yourself in the chat. Tell us where you're tuning in from tonight and what grade and subject that you teach. Just a reminder before we get started too, make sure you set your chat to everybody, not just hosts and panelists, so that everyone can see your chat. Again, if you're just coming in, go ahead and introduce yourself in the chat and we'll get started in just a few minutes. All right, well, everybody's coming in. Just going to go over some quick housekeeping before we get started. Again, just as a reminder, make sure that you switch that chat button in the Zoom to everyone. That way everyone can see what you're putting in the chat, not just the hosts and panelists. Go ahead and introduce yourself in the chat. If you have any questions during the presentation, please go ahead and use the Q&A feature in the Zoom, and that way we can answer your question. Our fabulous behind-the-scenes moderators can answer your questions live, and then we will also have a Q&A at the end of the session to answer any outstanding questions. And again, just as a reminder, this will be recorded and emailed after the webinar along with your PD certificate. Just give us about 2 business days to get that to you. I'm going to introduce myself real quick. I'm one of our presenters today. My name is Adrienne, and I am an education content manager here at Sphero. I spent 12 years in public education before coming over here and taught engineering and robotics and math. And I'll let Alyssa introduce herself real quick.
Hi there. Thanks, Adrienne. I'm a product manager at Sphero. That means that I get to manage our cross-disciplinary teams that are working to design all of the robots and products that you use in your classrooms. I'm an engineer by training. I went to school for engineering. I majored in electromechanical and did some work at a series of robotics and engineering companies before making the move to product management at Sphero. I did get into engineering via my high school robotics team. So a lot of the really cool stuff that you guys see today is really relevant to me.
Awesome. So just a quick agenda. We're going to be reviewing what the Blueprint Engineering Kit is. Some of you may be familiar with it, but if you're not, don't worry, because we're going to go over everything you need to know about the Blueprint Engineering Kit. We're going to go over our content and resources, as well as our CAD and 3D printing guides. And then at the end, we'll have a Q&A and, of course, a giveaway at the end of the presentation.
All right, well, we'll start by introducing you to the Blueprint Engineering Kit. As an overall view, Adrienne, if you go to the next slide, this is Blueprint. We're hoping to teach mechanical engineering, electrical engineering, and control systems basics with the contents of this kit without the need for programming. So students are going to be able to get introduced to topics like statics and friction and math and electrical engineering without the need to pull out a computer and without the need to do any type of hard coding. So we see this as a really great intro to engineering offering for students that are really high aptitude, that might be able to do really, really well in engineering, but maybe haven't seen themselves in that space before. This is a really great stepping stone into getting excited about engineering and math. I'll start with the mechanical pieces. So the mechanical portion of Blueprint is what some of you may already have. It's been out on the market for, I think, a little under a year now, which is really exciting. And it teaches mechanical engineering and mechanical physics. So you have a combination of weighted and non-weighted trusses, which are the main building components that you're using to build your structures. There's all sorts of plates that you can add for reinforcement, connectors, hinges, screws. They teach all the different type of locking mechanisms. There's shafts and shaft collars, and these are able to be implemented without the use of tools. As an engineer, I've worked with a lot of engineering products that require all sorts of, Phillips head, flathead, star head, power tools, all sorts of stuff. And we're able to use our shafts and our shaft collars without the need for any additional tools, aside from the removal tool that you see in the bottom right-hand corner that we provide for you in the kit. And that just makes it easier to press things into small places and pop connectors off of trusses. There's also pulleys, tires, and strings, and a hand crank for any of the gear combination lessons that we'll get into here in a little bit. So this is the mechanical portion of the Blueprint ecosystem.
And as I saw some people say in the chat that some people actually already have part of the Blueprint kit. And at the end of the show, I'll show you a picture, but Michelle did point out in the chat that if you already have the build kit, you will be able to purchase the add-on kit called the Bit Kit that will come with all of the electrical pieces that you see on the screen right now that we're about to go over, so that you'll have everything from a complete, or to make a complete Blueprint engineering kit. So here's just a quick overview of the really exciting electrical and powered pieces that we are adding to the Blueprint engineering kit. We're going to go over each one of them. So I'm going to go off of this slide, but you'll see what all of these bits do in just a second. So first, every circuit is going to start off with a power bit that you see on the screen. These can be charged via USB-C or with the multi-charger that you see on the screen that would come with a class pack, where you can charge up to 6 batteries at a time on one charger. The really cool thing about the power bit is that you can make 2 circuits from each power bit. So you can see in the GIF here that you can actually add bits to either side of the power bit, basically being able to create 2 independent circuits from one power source, which is pretty unique. The next bit that is very important to the Blueprint engineering kit is our motor bit. And the really, really cool thing about this motor bit is it can act as a motor or a servo. And so you have 2 different modes, being a velocity mode, which is like a normal motor. It just spins constantly in one direction or another. And you also have position mode, which basically allows the motor to swing like a servo, 180 degrees. If you don't set it to anything else, that's its default, but you can also adjust that swing through other bits in the kit so that you can basically just have one bit, but it can provide 2 different modes for you. And in each of those velocity and position mode, you have the option of being in positive or negative mode, depending on which direction you want to be going. And so that's 4 different modes total, and all in one bit. So it is pretty cool. And I'll hand it over to Alyssa to introduce the rest.
Perfect. Next up, we have the button bit. So these are all of the next few bits that we're going to get into are all bits that you can use in any combination coming off of that power bit or a motor bit. And each bit gives the bit directly next to it the signal that passes through. So the button bit is a really great example of a simple input that is going to pass over to the next bits in the system. And it has 2 states, pressed or not pressed. The signal only passes through when the button is pressed. So this is just showing that kind of flow gate that you'll see in limit switches, buttons, etc., in different engineering systems. Next up, we have the LED bar bit, which is one of my favorite bits. It's really fun. It brings light to your builds. There's 3 different modes on it. There's brightness, there's color, and there's a bar graph. So depending on the amount of the signal being passed through, so for example, with the button bit, when it's getting 100% of the signal or 0 signal, you're not going to get what you're seeing here. This, we'll get to the potentiometer in a minute here, but you're seeing kind of the dimness go up and down. You won't get that if you have, say, a button bit plugged in front of it, because you'll just get either 100% light or no light, which is really great. That's what we're trying to teach with signals being passed through. You can either give 100% of a signal, no signal, or variations of the signal. So the 3 different ways that the LED bit will show those things are through brightness, where all of the LEDs will kind of dim really, really low and then get a lot brighter. There's color, which will go through a full spectrum of color depending on the input being received. And then there's the bar graph, which is, I think, about to be shown here in the GIF.
Yeah,
This is the
accurate.
color mode, and then the bar graph starts in the center. This is the bar graph here. So it's giving you either 100% or negative 100% signal. So those are the three different modes. The threshold bit is pretty cool. This is one that I think really clearly shows programming without the need for code. This one is really giving students the ability to set the dial to a value between negative 100 and positive 100. There's two buttons on it. It's the greater than or the less than button, and the signal will only go through when the threshold is met. So say you have a motor in front of a threshold bit in front of an LED graph, and you set the threshold to only count when you're getting above 50% signal. The signal will not pass from the motor through the threshold to the LED bit until the motor has done its 50% cycle. So it's a really cool bit that's showing those kind of early stage programming if then concepts without the need for, again, pulling out a laptop. This is the distance sensor bit. The distances are measured up from 0 to 1 meter. And again, this is going to pass that amount through to the next part of the signal. So what you're seeing here is the data display bit, which is my favorite bit in the system, and we'll see that next. But say you had an LED bit plugged in after the distance bit. If you were to move your hand up and down away from the distance bit and you had the LED bit in the brightness setting, basically the further your hand would get away from the distance sensor, the brighter the LEDs would shine, and vice versa. So again, you're able to choose how much signal or signify how much signal is passing through from one bit to the next via the inputs that are being read. And this will work up to 1 meter accurately. And then the data display bit is a really cute little bit. You can kind of use it as a debugging tool and plug it in wherever you want in your circuit as a way to see information about the bit in front of it. So if you are using your data display bit right after a motor, which is what you're seeing here in the GIF, you can see the velocity, you can see the current velocity, you can see the target velocity, you can see the current position, the target position, etc. If you had the LED bit plugged in, you could see what color it is. If you had the threshold bit plugged in, you would see a yes or no if it's being met by the threshold. If you had your button bit pressed in, it would be the same thing. So you can see all sorts of information about the bit in front of what the data bit is plugged into, which is pretty cool.
Yeah, the data display bit is like my favorite bit in the whole kit. And just being able to like in real time see what's happening in your circuit, depending on where it is, just makes all of the information that's being displayed so much more relevant to
Yes.
students. And I just really love having it in my builds.
Yeah. It's a really
So
cool way to get numbers and information from your builds while you're working.
yeah. So we're going to move on to the lessons and resources part of our presentation, which is probably my favorite part because that is what I do here at Sphero. But one of the really important things that we like to share with our audience and our customers here at Sphero, our content team and a lot of our company is made up of former educators. And specifically when developing Blueprint, we really wanted to create a product that started with the content that we wanted to teach and then developed a product around that instead of the other way around. And I think that the way that Blueprint works and all of the features that we have in the different mechanical and electrical pieces really showcases that content first approach. And so Blueprint on its own is a super cool kit, and you can do all sorts of stuff with it. But the content and the resources that we provide, we feel like is really what makes our product shine. So I want to go over what that looks like. We have lots of different lessons and resources, but the main kind of meat of all of that is our 4 units of curriculum that are currently on edu.sphero.com, which is our Sphero Central site where you can get all all content about any of our Sphero products. So those 4 units are broken up into simple machines, A classroom carnival that reinforces those simple machine concepts, but in a more fun and interactive way. Control systems, which starts to use the powered bits and really teach, like Alyssa was talking about earlier, um, that concept of kind of putting together a control system and using and kind of doing the logistical programming without actually having to open a device. And then the last unit, which we just recently published, I think last month, is machines in our food system, which follows our food system from farm all the way to like waste disposal and recycling, and looks at different machines and engineering, historical engineering products in that whole system, and has students work through the engineering design process while also kind of learning about that system as a whole. It's a really fun unit. You can see the build on the bottom is actually from that unit, and it's a 3-point tractor hitch where students design their own accessories to go on the back. In the upper right-hand corner, you can see an example of an inclined plane from the simple machine unit. And then next to that is actually from the carnival unit, and it's representing a teacups ride. And so all of these builds that you see on the screen right now are in our content. And we actually provide a bunch of resources for that content, which I'm going to get into in just a second. But this content we really feel like fits into STEM and engineering classes and different CTE career clusters that we see in the middle school and high school level right now. So in that content, every single lesson in that content is going to give you 4 different resources. All of those 4 resources, most of those resources are in the Google suite of products, so Google Slides and Google Docs, and you are able to, save them to your own drive, make copies, change them up, use them as is. It's kind of up to you. We know all your classrooms look completely different, so we wanted to give you the basis of these lessons, but also give you some flexibility so that you can make them whatever you want. So the first resource that you'll get with every lesson is a Google Doc teacher guide that walks you through the lessons, gives you tips on how to teach that lesson to your students, questions, responses, all the stuff you would find in a teacher guide for any curriculum. Then we also provide a Google Doc version of a student handout. So as you're working through the activity, the students can do calculations for mechanical advantage, sketch out their designs, work through the engineering design process. And that document can be used as a digital submission, or it can be printed out and used as a handwritten submission, and it will work just as well either way. Then we also provide a presentation via Google Slides. So to put up on your projector, be able to work through the lessons with your students like that. And then the last resource we provide for each lesson is a set of interactive build instructions. These are what's actually not part of the Google Suite, but it is just a URL link to all of these, and they put you into a website called Cadazio, and that way you can click through the instructions. They'll be animated step by step. You can rotate, you can zoom in, you can zoom out, and it's really interactive and makes building the builds for these lessons really, really easy for teachers and students alike. And then one of the other content options that we have for the Blueprint Kit are our challenge cards. We have 10 of them. If you already have the build kit, you've already seen 5 of the challenge cards. And then in the engineering kit or the upgraded bit kit, you would be able to find the other 5 challenge cards. And these are just really quick printed out cards. You can also access them through a PDF on our website. That really get students quickly involved in building something out of Blueprint. So you can see the example on the screen right now is from challenge card number 5, which is called Gone Fishing. And it challenges students to create a fishing pole using their blueprint parts, and they have certain criteria that they have to meet when building that. All of these also come with optional student handouts that walk students through the engineering design process. So you can really use these as activities that are graded and really, really thorough. Or I sometimes like to call these the Friday before Thanksgiving break or the Wednesday before Thanksgiving break activity, where you just need something to do. It doesn't need to be like super, super involved, but you want your kids to be engaged and learning. You can just use it as a quick challenge. With all of these curriculum and lessons, we also have a ton of other resources available on our website. And I believe that we just got the link posted in the chat there for these. So you can go to this link and see we have educator guides, the PDFs of those challenge cards. Video libraries, and even what we like to call the Blueprintopedia, which lists out every part in the blueprint kit and just gives you a better description and some options of how you can use either the mechanical pieces or the bits. And there's even more things on there that we're actually going to talk about in just a second in our next section. And so I'll hand it back over to Alyssa.
And that would be CAD and 3D printing, which we also have a ton of resources for on that research page that Adrian just called out. So something about the blueprint kit that we were really, really passionate about is we're trying to hit that potentially low aptitude, or high aptitude, but low confidence student. We want to make sure that we're also leaving a lot of room for growth. So students or educators that get really comfortable with the blueprint kit, feel really confident in it, and are also interested in pursuing CAD, 3D printing, or maybe some more complicated engineering work. We wanted to make that resource available to them and that capability available to them. So if you go to the next slide, you'll see that we have all of the CAD files for every single blueprint part available for download online in three different forms. There's SolidWorks part, which is SolidWorks parts and assemblies. So we have assemblies of all of the builds, along with parts for every single individual component. You can also download them as step files, which you can use to upload into any 3D programming software that you're using. So that's available for you, and STLs, which is really helpful if you're trying to do any 3D printing specifically. There's Onshape documents as well. Those have tutorial videos attached to them, which is an extra bonus. And there's a complete CAD guide to help you get started with using Blueprint and CAD. If you go to the next slide, one of the things that's in that Blueprint CAD guide is some 3D printing resources. So if you were to download the SolidWorks part for our integrated connector, you can start with that little piece that you see in the top right-hand corner, take that file, make a copy of it in SolidWorks, Onshape, Fusion, whatever you and your students use, and then build whatever you want on top of it. Once you've designed your whole part, attached to that little core component piece, you can go ahead and print it out on your 3D printer at home, and it'll snap right into your blueprint build, which just gives you so much room to grow once you feel comfortable with the blueprint system. If you want to take it and run, create your own lessons, your own curriculum, your own challenges for students, or just give them open-ended challenges with the use of a 3D printer and some CAD, it's all available for them and downloadable online. There's also a specific user guide for 3D printing and blueprint parts. So if you're looking to get started with 3D printing, and maybe your school bought a 3D printer and it's sitting in the corner collecting dust and no one's quite sure how to use it, you can go ahead and get started with our 3D printing guide, and that'll give you a really great baseline model for getting started really easily.
Yeah, and we really tried, like Alyssa said, to make this super easy to start up. We know a lot of teachers have 3D printers in their classroom that are not really being utilized, and it's hard to kind of create a lot of material around that. So we, specific to our lessons and our challenge cards, we provide already done STL files that can snap right in and just kind of bring more life to your build. So this is an example on the screen here. There's an iconic skyscrapers challenge card where students research different skyscrapers that are from around the world that are interesting or look pretty cool. And this is an example of a spire that you can just print out to put right on top of your skyscraper and just make it look a little bit more cool or a little bit more realistic. for maybe shapes that you can't create out of the blueprint engineering system. Now, we know that, not all teachers are going to utilize these CAD and 3D printing resources. But like Alyssa pointed out earlier, we really wanted to offer the option for students and teachers that want to take this kit kind of to the next level. So none of this that we're talking about, if you're like, oh, I can't do CAD, I can't do 3D printing, we want to be able to provide you the resources to at least get there. But if that's not part of your curriculum or something that you think you're going to do in your classroom, all of this is definitely not necessary to have a really good experience with the blueprint kit. And I do see a question in the chat about STL files. On average, how much time would it take to print out? Most of our files are pretty small. Time for printing is really going to depend on your material and all of the settings that you put in on your 3D printer, like infill and the type of structure that it's going to put in. But I would say on average, most of the files that we've provided are a couple hour print usually. So not something that's going to take you overnight or a few days or something. They're usually smaller and a little bit more manageable. But again, all 3D printers are different. So it's kind of hard to put a really good estimate on that. But that is a good question. Now, obviously, with the starter plate and being able to, design your own decorations or functional pieces for the blueprint kit, those, depending on how big you or your students make them, can take longer than that. But, that's about as close as I can get. We didn't, none of the examples that we provide are too terribly big. So.
And we do also have all of the settings already set up for some really common printers in that 3D printing guide. So I saw James Holloway, some people are using 3D printers all the time, and that's fantastic. But if you happen to not be using them a lot, there's all sorts of settings available for that as well.
Infill percentage that we recommend for all of the sample parts that we give, most of them are non-functional. And so I would say you can get away with a lower infill. I don't know, the 3D printers I usually keep the infill around like 70%. But like I said, these are like decorational, so I bet you could go lower and not really feel like anything's going to break off or something. But I would say for functional pieces, if you're designing your own, I would stay up above that range. Last little part of our presentation is Blueprint in the classroom. We just wanted to show you Blueprint in action in some classrooms that we've already seen students having some fun with their Blueprint. So you can see over on the left-hand side of your screen, we had a teacher that was using the challenge cards of being able to design a rubber band powered car and the iconic skyscrapers kind of behind it. And so those are some building examples of what students have done with those challenge cards that we talked about. Over on the right side of your screen, this first picture on the top is actually a lesson about pulleys and construction cranes. That's included in our simple machine unit. And then also that same lesson on the bottom left-hand side. On the bottom right is again that rubber band powered car lesson and challenge card. And so just some examples of teachers and classes that have been using it. And then this again is that iconic skyscraper build and just some kiddos that had some success with that. And on the left-hand side of your screen, and then on the right-hand side of your screen, these students are building the inclined plane simple machine and going through that lesson. You can see on their device right here, they have the interactive build instructions up, and then this is their inclined plane build that they're using or that they're building right now to just learn about how that simple machine can make it easier for you to lift heavy weights up and down. So
To
last,
answer one,
oh, go ahead.
Oh, I was just going to go ahead and answer one question that I saw in the chat.
Okay.
You can go really big with these blueprint kits, especially because the plates exists to give some extra reinforcement. So as long as you start your base big, you can go really as tall as you want. One of our Sphero employees actually just worked on a build a couple weeks ago that's this big, like 3 foot by 2 foot tractor that's fully interactive and drives forward and backward and has a bunch of different subcomponents. I've seen skyscrapers that are as tall as me, so 5'5". You can go as big as you are willing to reinforce.
Yeah, and I would say from one kit, in our content, you can build anything that's in our content from one student kit. To make some of these bigger builds, you may have to use multiple student kits. Or in the class pack, we do include an accessory pack that gives extra pieces so that students can either build bigger than just one kit or to replace missing parts from kits as things get lost and misplaced. We know that never happens in anyone's classroom, but just in case, we wanted to provide some extra pieces so that you can refill those kits that maybe get a little empty. So I know that we've talked about this in the chat so far, but I did want to mention that the engineering kit includes mechanical and electrical pieces. We did previously, for the last few months, sell the Blueprint build kit, which was only the mechanical pieces. If you are on this call and you have a build kit, first of all, that's awesome. And we hope you're having a lot of fun with it. But second of all, if you want to upgrade that to a Blueprint engineering kit, which will include all of those electrical pieces, you can purchase the bit kit. And so then those two bins together will give you a full engineering kit. Now we've talked a lot about the electrical pieces that are in that build kit, but it does also come with some additional mechanical pieces, which is pretty cool. So you can see in this picture, we have these 5x5 plates that will help you, with those bigger builds, some larger gears, some rack gears so that you can make linear motion easier. These catapult end effectors, and then also these little gray clips down here to help with wire management and just kind of keep your wires neat and tidy on your build so they don't get in your way. So that is kind of the kits. If you have one from Global Challenge, that is a smaller version of our build kit. And so it does not include all of the pieces, all of the mechanical pieces that are in an engineering kit. And it also doesn't include any electrical pieces. So it's definitely a good thing to get you started, but I would recommend if you're going to use any of our content that you, upgrade to the engineering kit, since that's a curated Blueprint kit specifically for the Sphero Global Challenge. So the pieces in there just kind of are irrelevant to our other kits. So.
There was a question. Oh, I was just going to answer one more question from the chat, which it looks like Paul took a stab at as well. The whole thesis statement that we started with when we started designing Blueprint and Blueprint engineering was definitely trying to keep the complexity relatively low. You can go as complex as you want if you want to work outside of a class period, but we did aim that every build can be assembled and disassembled within one class period. Every build that we provide can be disassembled within 5 minutes at the very end of class, which was a huge goal of ours. But when you get more advanced, if you want to have projects that go from class to class and that are getting bigger and more complicated, you can use these bits to really do just about anything. With the threshold bit and the motors, you can basically program an entire closed loop control system to operate a car for as long as the distance sensor doesn't go within a meter, which is a pretty complex topic and a pretty complex idea, but you're able to do that. And we've been estimating the most class periods are about 45 minutes.
Yeah, so most of our content that is those like basics, like learn about what a simple machine is and how it works. We really tried to structure those lessons so that in 45 minutes you can make the build, learn from it, and take it apart. Once you get into the more complex lessons where you're actually going through the full engineering design process, we do estimate between 2 to 5 class periods on some of those lessons, just depending on how detailed that you want to go with your students. But yeah, for one class period, we say 45 minutes because we find that that is I was a high school teacher for a long time, so that's usually a one high school period or one middle school period, unless you do block scheduling where then it's a little bit longer. Um, the other question I saw in the chat, can Blueprint integrate with Unreal Engine or Unity 3D? Unfortunately, I don't have a good answer to that because I'm really unfamiliar with both of those things.
Anything, I
So
was
I
gonna
would love
say
to hear more
anything that
about that.
accepts, I don't know those either, but anything that accepts a step file will work with this. I'm unfamiliar with both of those softwares as well, so I definitely want to look into them. But anything that allows you to upload a step file will be golden.
So we do have a couple of poll questions for the audience. I believe Cassie is going to throw those up there. Um, I don't. There we go. There's the first one. So the first one, Blueprint Engineering poll. We would love to hear what grade levels you intend to use your Blueprint. If you were able to get a Blueprint kit, what grades you would be using it in. We just a quick note that we officially recommend it for grades 6 through 10. That's where we tried to hit our content. But we know that, y'all are awesome and take products and do stuff that we don't we don't ever even think about. So just wanted to take a quick poll. So I'll give you a couple more seconds to input your answer. Looks like a lot of middle school, which is good.
Perfect.
That's
Yeah.
like I said again, we wrote most of our content with that kind of seventh to eighth grade grader in mind. But we know all schools are different, and all programs are different. So, um, all right, I still have a couple more answers coming in, so I'll just give it a few more seconds. Okay, I'm going to end this poll, and then we're going to have one more poll question come up. This is the first time I've used a Zoom poll, so
This
I'm
is cool. I've never
excited
seen
to
this. It
see
was
how
cool
it
to see
works.
all the answers coming in.
Cassie here. Both questions were in there and people
Oh,
answered.
both questions were in there. I just had to scroll down. Thanks. Second question was what subjects do you see using Blueprint for? So it looks like a lot of you said STEM and robotics and engineering and general classroom activities as well. So that's really great to hear. So thank you for putting all those answers in there. And now we're going to move on to the Q&A. I think we've hit most of the questions that were in the chat so far, but if my mods could just make sure that you tell me if I missed one, that would be awesome. I see we have a homeschool, so it'd be great for the older kiddos to work with the younger elementary. That's an awesome idea. I ran a robotics program for a long time at my old school, and I saw some of the best moments come out of older students mentoring younger students, especially with kits like this where they can kind of all be on the same level. We'd like to incorporate it into our Space Adventure Camp. That would be awesome. We'd love to hear more about that. If you want to shoot us an email at training@sphero.com, that would be really cool to see what.
That's a really cool idea. Dixie works in a makerspace with a lot of 3D printers and doing a PD for teachers specifically, but using Blueprint to teach them how to use the 3D printers would be really, really cool.
Yeah, I love that idea. And that's definitely what we had in mind in making some of these resources is giving y'all the ability to kind of integrate this stuff really, really easily. So that's awesome. Well, we have reached that time that is the most exciting time of the night, which is our giveaway. So we are giving away a Blueprint Engineering kit to one lucky winner, which is going to be Cindy Thorne. So congratulations to Cindy for winning our Blueprint kit. And we appreciate all of you coming to this webinar tonight. We hope that you learned about our kit and about our content and are thinking of all sorts of awesome ways to integrate it into your program. So we appreciate everybody joining us again, and have a wonderful evening.
Thank you all so much. Have a great rest of your day.
Just a reminder too, we should be sending you an email with a recording of this and a PD certificate within 2 business days. Make sure you follow us on socials if you're not already. All right, thanks everybody. Have a great night.